All right, so what we're going to be doing now is we're going to be solving these quadratic inequalities using numbers as a test, and so you'll find out how that works here. So we're going to solve each inequality, and then we're going to graph the solution set. So what we want to do first is when we're going to solve these guys is for the time being we're going to ignore the inequality, and again the whole word inequality means not equal. So meaning that I just mean like we have a statement that's not necessarily equal. Now when it has a line underneath it, then we're going to say that the left side can be equal to the right side, but that doesn't mean that's going to be the case at every time. So when you have equal sign, that means that we have an equation, meaning that the left side should always be equal to the right side. But when you have an inequality, then that means that it's not balanced. You have a left side that's not going to be quite equal to the right side. So let's check this out. So the first thing that we want to do here is set this actually equal to 0. That's what we want to do here. So 4x squared minus 9 equals 0. And what we want to do is that we want to find the zeros of our quadratic. Okay, so we want to find the zeros. And the zeros are the same thing as saying the x-intercepts. Okay, so really we want to find the x-intercepts of this quadratic. And the way that we do that is we factor, or we can solve. In this case, we're actually able to solve here. So what we'll do is that we'll just go ahead and add the 9 over here to both sides. And we'll get 4x squared equals 9. And then we'll get rid of the 4 by dividing by 4 on both sides. So we get x squared equals 9/4. And then lastly, we want to solve for x. So we're going to get rid of the square by doing the opposite operation of squaring, which is the square root. So we'll take the square root of both sides. And don't forget that since we are the one introducing the radical sign symbol, that means that we have to do plus or minus. So it's plus or minus the square root of 9, which is 3, and the square root of 4, which is 2. Okay? And you also could have factored this as well. You can actually factor 4x squared minus 9 as 2x plus 3 times 2x minus 3 is equal to 0. So then you could have set each factor equal to 0 and then get the same thing, 3/2 and then negative 3/2. So it just depends if you wanted to solve like I did here, or you could have factored the entire left side and got that. Okay, so but the problem didn't say solve the equation, it says solve the inequality. So we want to know, when is this quadratic? And the reason why I'm calling this a quadratic because it has a power of 2. Okay, so any function that has the highest degree of 2 is called a quadratic. So when is this inequality less than or equal to 0? All right, so that's the question there. And the way that we're able to figure that out is we're going to use a number line. So what you do here is you make a number line, and we're going to use the two values that we just found right now. We found out that one of the values is 3/2, and the other value is negative 3/2. And then I'm just going to say that 0 is right here in the middle. And not that really is important to put 0 out there. Actually, that may be confusing for what I'm going to do right now, so I'm going to get rid of that 0. So basically what you want to do is make a number line and just plot the two values that we just found when it's equal to 0. So now check this out. What we want to do now is we have now divided the number line into 3 sections. We have a section A, B, and C. So we have everything over here, everything in between, and then everything over here. And basically we want to figure out, is it true or false in here, true or false, or true or false? What do you mean by true or false? Meaning, if I pick any number in section A and if I plug it back into my quadratic, is it really less than or equal to 0? And if it is, then we're going to put a T. But if it's not, then we're going to put a false. Okay, so that just depends on whatever the outcome is here. And then we're going to do the same thing for section B and for section C. Okay, because this inequality means, when is this quadratic less than or equal to 0? So once we know when it's equal to 0, we want to figure out, okay, so now when is it going to be less than 0? So that's what we're interested in right now. Okay, so let's pick a number anywhere in here. Again, negative 3/2 is negative 1.5. So, I mean, it doesn't really matter what we want to do here. Maybe we'll just pick a negative 3. Okay, so what I'm going to do is I'm going to plug in negative 3 right here. So 4 times negative 3 squared minus 9 is less than or equal to 0. Is that true or false? Well, negative 3 squared is 9. So 4 times 9 minus 9. Is that less than or equal to 0? It's looking like a false right now, right? Because this is going to give us 36 minus 9 is less than or equal to 0. So this most definitely, oops, that should have been 0 right there. So this most definitely is going to be false. So I'm going to go ahead and put a false right here. I'm going to put false. So everything over here is going to be false. No, none of these numbers over here, it doesn't matter if I do negative 100, negative 1,000, negative 1,050, we're always going to get a false answer. So everything here is false. Now what about in the B range? Okay, and I'm going to pick the easiest number, which is 0. So I'm going to go ahead and plug in 0 into here. 4 times 0 squared minus 9 is less than or equal to 0. Well, 0 squared is 0, right? 0 squared is 0. So 4 times 0 minus 9 is less than or equal to 0. 4 times 0 is 0. And 0 minus 9 is negative 9. So is negative 9 less than or equal to 0? Well, that's true, right? Well, yeah, that is. Negative 9 is less than 0. So this is going to give us a true statement here. So I'm going to go ahead and put true. Now, what about numbers that are bigger than 3 halves or negative 1 point or a positive 1.5? So we can just do a positive 3. So if I do positive 3, maybe like I'll just do that up here. 4 times 3 squared minus 9 is less than or equal to 0. And we're going to get the same answer over here, because if you square a negative, it's positive. If you square a positive, so we're going to get, you know, the same thing. 36 minus 9 less than or equal to 0. So this is also false. So false. Okay, so this may look really confusing. You're like, dude, what the heck is going on now? All I want to know is, like, when is this less than 0? So, well, when is it true? It's true in the middle right here. Meaning it's true from negative 3 halves to 3 halves. So the answer is going to be bracket negative 3 halves, comma, to 3 halves bracket. You say, why are you using brackets? Good question. So you use brackets. I'm going to kind of scroll down here. You use brackets, okay, when the inequality is less than or equal to or greater than or equal to. You use parentheses if it's less than or greater than. Notice the difference? See, this line underneath the inequality means equal to, meaning that it's included. So the brackets means you can use the number in the inequality. You say, what do you mean? Well, if you were to plug in the actual number negative 3 halves, if you plug in negative 3 halves, the left side becomes 0. Oh, so 0 is less than or equal to 0. See the equal sign? This little line means the equal sign. You mean like it's equal to. So you could actually plug in these numbers and it's still true. And if that is the case, then that's when you're going to use the brackets. But when it doesn't have the inequality symbol with the line underneath it, then you're going to use parentheses. So this right here would be the answer. And we also need to graph this as well. So let's just come back up to our number line. And so really the answer that we're actually looking for, and I'll just erase all this. Oops. So really all that we're looking for, so that's negative 3 halves. 3 halves. You can use bracket, and then it goes just like that right there. That's the answer that we're looking for.